Since we know that anything to the 0 power is 1, 6 to the 0 is 1, y to the 0 is 1, negative 1,000 to the 0 is 1, and even a product like 3abc to the 0 is 1. With negative exponents, we know it means to take the reciprocal. So 3 to the negative second power is the same as saying the reciprocal of 3 to the second power. And then we know we can keep simplifying so that this is 1 over 9, since 9 is 3 squared. In the next problem, we see 3a b to the negative third, and it's important to realize that the only thing being affected by that exponent is the b. So this is like having 3a times 1 over b to the third. But if you think about that, when you multiply a whole number by a fraction, we usually put a 1 underneath the whole number. And then we multiply straight across the numerators and straight across the denominators. So we have 3a divided by b cubed is equivalent to the expression we were given originally. A lot of times we'll skip that middle step and just go straight to moving b to the negative third into the denominator, leaving 3a in the numerator. In the next problem, we have negative 8 to the negative first power. So that means take the reciprocal of negative 8 to the first power. But we know that the first power doesn't do anything. It just means we have one of them. We also know that we shouldn't leave a negative in the denominator. So while at first we might think this is 1 over negative 8, we know that we should take that negative out in front of the entire fraction and write negative 1/8. Now this problem looks a little bit different, but if you remember that a negative exponent means take the reciprocal, it won't be so bad. Since x squared is in the denominator, x to the negative squared is in the denominator, we can think of this a couple ways. One option is to think of this as 1 over x squared. And that's likely to make us panic for a minute until we remember that the way you divide by a fraction is to multiply by the reciprocal. So the 1 from the numerator would be multiplied by the reciprocal of the denominator. Noticing that 1 divided by 1 is just 1, this whole thing is just equal to x squared. So the problem looks much more complicated than it is. A lot of times it helps to think of the negative exponent as telling us that the variable is where it doesn't want to be. So when we had a problem like this, where the variable was in the numerator, we moved b cubed to the denominator. But here we have a variable in the denominator, so the negative exponent is going to move it to the numerator. In our next problem, we see a 5 and a y, which don't have any exponents, so they're not going to move anywhere. The x squared to the negative second is in the numerator, which means it wishes it was in the denominator. The z to the negative first power is in the denominator, which means it wishes it was in the numerator. There aren't any negative exponents left, so that's our final answer. In the next problem, we have a combination of rules. First of all, the 5 and the c squared don't have any negative exponents, so they're not going to go anywhere. Secondly, that a to the 0 we know to be equal to 1. And since 5 times 1 is just 5, it basically disappears. So in the numerator, we have a 5, and in the denominator, we have a c squared. The 2 to the negative first belongs in the numerator, because that's where taking the reciprocal would bring it. So this is a 5 times 2 to the first. The b to the negative third belongs in the denominator, because that's where the negative exponent would take it. So we have a b cubed in the denominator. Finally, we can simplify a little bit further. We know that 2 to the first is just 2, and 2 times 5 is 10. In the denominator, we still have b cubed c squared. Next, we're asked to evaluate. Evaluate means to substitute the values in place of the variables and then to simplify. Sometimes it helps if we simplify the expression first. So if we look at this 4x squared times y to the negative third, remember that y to the negative third means that the y wishes it was in the denominator. So the expression is really 4x squared divided by y cubed. Next, now that we've simplified the variable expression as much as we can, it's time to substitute some values. If x equals 3, then 3 should be put in place of x. And if y equals -2, then -2 should be put in place of y. So this expression would equal 4 times 3 squared divided by -2 cubed. So following our order of operations, we would start by applying the exponents. So 3 squared is 9, making our numerator 4 times 9. -2 cubed means -2 times -2 times -2. 3 negatives will stay negative, and 2 times 2 times 2 is 8. Now, we could multiply 4 by 9 and get 36 and then reduce that fraction. Or we could realize right here that 4 goes into 8, leaving a 2. So we could reduce that fraction. We also know that we shouldn't leave that negative in the denominator, so we're going to say that this is the opposite of 9/2. In the next problem, again, it helps to simplify a little bit. This x to the -2 belongs in the denominator. So we're going to have 2 over x squared y squared as the simplified version of that algebraic expression. Then we're going to substitute in a 2 for x, a -2 for x, and a +5 for y. And this becomes an arithmetic problem. We have 2 in the numerator divided by, we know -2 squared means -2 times -2, which is equal to 4. And that 5 squared equals 25. Again, we can make life a little simpler if we realize that 2 goes into both 2 and 4, leaving a 1 in the numerator and a 2 in the denominator. So this leaves 1 over 2 times 25, or 50. Next, we have a word problem. It says a population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the w, where w is the number of weeks after the population was measured. We're asked to evaluate the expression for w equals -2, w equals 0, and w equals 1, and then to tell what each value of the expression represents. So first, let's just plug things in and do the arithmetic. If I have 5,400 times 3 to the -2nd. So that's using the first value for w. Remember, a negative exponent means something belongs in the denominator. So 5,400 divided by 3 squared. Applying the order of operations, we should square the 3. So this is 5,400 divided by 9. Now when you see the 54 in 5,400 and the 9, you should realize that 54 divided by 9 is 6. But since it was really 5,400, that's going to be a 600. Next, we substitute in a 0 for w. So we have 5,400 times 3 to the 0. We know that anything to the power of 0 is equal to 1, but also that the 0 is only applied to the 3 and not the 5,400. So this is 5,400 times 1, which is just 5,400. And finally, w equals 1, so 5,400 times 3 to the 1. So 3 to the first is just 3, so this is 5,400 times 3. Doing out that multiplication, we see that we get 16,200. All right, we've done all the arithmetic, but we're asked to explain what each of these expressions actually represents. So remember that w is the number of weeks after the population was measured. So if we think about that, it might work well to start with the 0. 0 weeks after the population was measured, the population had a size of 5,400. So that's basically telling us that when no time had elapsed, there were 5,400 insects. So that's actually the starting value. So when w equals 0, we have the starting value. The number of insects that was initially counted. Going forwards, if we have w equals 1, that means 1 week after the population was counted. So 1 week after the count, there are significantly more insects. In fact, 1 week after the count, there are 16,200 insects, significantly more. Now, if we look back at the other number, we notice that it's smaller than either of these two. and that the number of weeks is -2. So if we think about that, what does -2 weeks mean? Well, W equals -2 means 2 weeks before the count of the population. Since we see that the count of the population was 600 2 weeks before the count was taken, that means that the population was much smaller before they counted. So 2 weeks before the count of the population, there were 600 insects.